Right. Welcome everyone to this month's March In Like a Lion, Out Like a Lamb, I believe. Is that what March is? ELIXIR UK RDM Club. Today we have Gavin Farrell with us, who's going to be talking about AI and the open and sustainable AI work that he's been doing, including a really interesting review of the current landscape of AI tools, resources, standards. So thank you, Gavin, for coming and agreeing to speak with us. Please, would you go ahead and start your screen share?
Okay, so thank you very much for having me. I'm Gavin Farrell from University of Padua. Today I'll be presenting on open and sustainable AI, and something that's probably of quite a bit of interest to the folk and group here is the ecosystem landscaping of support for artificial intelligence and machine learning outputs. I'm based at University of Padua. I'm part of ELIXIR Italy through that with my guiding PI, Silvio Tisato. But also I do a bit of work with ELIXIR Ireland, so I also do have the logo there. But the scope of this work is largely from the PhD that I'm doing with the University of Padua. So a bit of a context and how we actually got to our next set of guidelines, which is the Open Sustainable AI resource, is ELIXIR's DOME recommendations, which kind of set the ground and landscape for a lot of this work that I'll be talking about today. So the DOME recommendations were these machine learning publishing best practices. So this was published in Nature Methods in 2021 by the ELIXIR Europe Machine Learning Focus Group. I've linked to the fair sharing registered entry of that there, which you can find more info on this. And this was kind of the first point of action by ELIXIR Europe through the Machine Learning Focus Group to start addressing how methods are actually ending up in the publications, making sure all the right things are disclosed in there, and helping support the reuse of those methods and understandability. What DOME actually covers, it's an acronym standing for Data, Optimization, Model, and Evaluation. And across these four areas, which embody a machine learning method, there's around 20 different sub-questions and areas that should be disclosed transparently and clearly in your publication or your supporting methods documentation when you're publishing a method, to help the understandability and transparency of that method and the best value and return for others who are reading it. So in the field of data, for example, making sure that there's clear disclosed data splits between your test and training, making sure that there's no data leakage, helping the reliability of the results that are being reported. For optimization, what even is just the algorithm that's been used as a convolutional neural network, a support vector machine, has this clearly been disclosed and some information on that. For the model aspect, is there even simply just availability of the software? Can you actually get back to that model that they've described in the publication text, but can you actually go and see that yourself and play around with it? Which is a huge part of trust as well. And then obviously on the evaluation side, making sure that people aren't comparing, for example, the comparison aspect, apples and oranges, that they're using clear benchmark data sets and actual fair evaluations in what they're reporting in their publication, to not make sure that they're having these claims of 100% accuracy, but they're actually not comparing it in a fair way or reliable and robust methods. Building on from the actual recommendations themselves, the Machine Learning Focus Group was funded with a strategic implementation study, and this was across a couple of ELIXIR nodes. And this project was to put together an actual place to host these annotations, these disclosures of the DOME structured methods. As you can see, a lot of the published annotations we do have are for GigaScience papers because they adopted this in their machine learning publishing workflow. So if they get a publication in, they mandate that there's this disclosure made, which is a supporting document. Then at the end, you can view on the registry and cross-link from your publication. And that helps describe the publication in the standard DOME format. But with the DOME recommendations and similarly the DOME registry infrastructure to share those and link those back to publications, there were some implementation challenges with DOME that were not yet resolved. It's fine to have these guiding advice pieces and these recommendations of what should be disclosed for your methods, but it really didn't go quite far enough to help the actual implementation and addressing these issues as well that researchers face. So some of the things that Dome didn't go quite far enough with that we decided we need some work on was the reusability and reproducibility challenges in a very practical sense. So again, we've the structured format with Dome for actually disclosing your machine learning methods, but it did not really provide enough on the specific output of the machine learning artifacts, which I'll be referring to. You might call them machine learning research objects or assets or other things, but I'll largely stick to artifacts for this, meaning the AI datasets and AI models, so the software related aspect of that. So the machine learning focus group decided then a couple of years later, so this was largely in 2025, let's start targeting this. And they set up in their monthly call together to start addressing reusability and reproducibility in a really grounded sense of how we can help support this and not just providing what should be disclosed, but how you can actually start doing this in a good way. And additionally, another big challenge that's been increasingly on people's minds with large language models and the resource energy glut and increased use of AI methods and especially deep learning methods in the life sciences and sciences in general is the energy use and the environmental sustainability. So I do have sustainability flagged, but this is specific to environmental sustainability, not just the sustainability of the asset itself. And here you can see that this was around 2025, and this was Trump saying AI needs a lot of energy, coal is the answer. So again, a bigger push to use fossil fuels, which is kind of rolling back the green energy movement, which again, if that's powering our big AI factories and so on, that's a bit of a concern. And ironically, last week again, he was there with all the miners, the coal miners. So you can't even make this stuff up, but he was named the undisputed champion of beautiful clean coal. So again, it doesn't seem like things are changing anytime soon, and if anything, getting a bit worse. So we need to be conscious about the environmental impact if this is how we're powering our AI factories and data centers. So this led us to open and sustainable AI, OSAI, which I'll be describing in the following slides and the OSAI recommendations. So as mentioned, Dome left gaps with the recommendations. They cover many technical areas, but lack the concrete grounding in tooling and implementation supports, and the environmental sustainability was completely absent in that. And the solution then was these OSAI recommendations that the machine learning focus group came together to work on. And it looks at the entire, or at least intends to, AI machine learning ecosystem of meta support. So how we can start capturing and making these available and tracked for different the scientists actually use rather than just providing guidance of what and saying what you should do. And this was led again by the machine learning focus group with 12 nodes involved. And there are many areas that we could have dived into, such as, and I do have the acronyms here and I do expand them later on, but RAI, so responsible AI, TAI, trustworthy AI, XAI, explainable AI, and ethical AI, which we didn't go into because they're socioethically complex. We didn't quite have the expertise, which was a barrier. And I did meet with people who do have ethical AI as a big focus in parts of their pillars and work, like the NIH Bridge to AI work. And I asked, how did you manage to get these expertise feeding in? We're life scientists, computer scientists, but and the answer was, well, we had an ethicist, which for us, with when you're doing this in kind, we didn't have the available support at the time to do so. So that's why we didn't address some of those areas. And because again, internationally, they're a bit more complex and nuanced, and there's constantly changing legislation, but there should be scope in the future to start addressing this where bandwidth and capacity allows. But for the scope of OSAI, we avoided them. So what we actually did then was we managed to get a preprint together. So this had the 12 nodes, and as mentioned there, and a huge amount of support from the UK node, and especially Carol and Shoaib, who were absolutely phenomenal with the support on this from the UK node. Very big members, I know, and active across many of the different groups and stuff you have going on. We got our preprint together in May of 2025, so it's almost a year ago now since we did this. We got a second version out later that year, and I do share the good news that it's been finally fully accepted by Nature Methods. I finished off and submitted the e-proofing yesterday, so hopefully April, maybe May, this should be available with a proper DOI in Nature Methods, and we can start pushing this out more widely. Now, actually going into the content of this, so OSAI, Open Sustainable Artificial Intelligence, what it actually involves. It's covering those three areas: reusability, reproducibility, and environmental sustainability. So one of the biggest things that we did was mapping some of the challenges and intersections across these three areas. There's a lot of cross impact between these, and again, how they're impacting the artificial intelligence machine learning artifacts, that AI data sets and models that are coming out, so the code related aspects. And if we look at barriers such as the reusability space and the issues that are coming out with when we're seeing these methods coming out in publications, is that there's a very low use of AI model and data set specific metadata. So FAIR for ML, which is a schema that can help, a metadata schema for models that can help with the standardized disclosure of those in a machine and human readable way, but also croissant standard, which is quite a popular and upcoming one for AI data sets disclosure. Similarly, for reproducibility, there's a huge amount of issues with just using the actual support, such as Docker containers, workflow management systems like Nextflow and SnakeMake, making sure that you've ease of reproducing those without having to trawl and try and do clicking step by step across those, which is quite common. And then the sustainability side, there's quite a lot of challenges, such as almost what do we even measure? There's so many different metrics that people could be looking at, which is a huge barrier. They don't know what tools to possibly use those. There's inadequate mandates for environmental impact reporting in your publications. For example, from funders, you might get funded to do all this cool artificial intelligence machine learning research, but there's no mandate or kind of push from anyone who's funded you to do so to start looking and reporting on that side of things. Obviously, in the larger, bigger data centers, there are from some of those funders, but at the smaller scale and distributed scale across labs, it's not quite a common thing that you'd see. And looking at the artifacts side of things, and again, this is open to interpretation, and people might disagree with the way I describe this, but I view that artificial intelligence machine learning outputs and the data sets are kind of unique assets and artifacts in themselves. And kind of this is very important for the research data management aspect of your machine learning methods and so on. So AlphaFold 2, for example, if we take that big landmark case and looking at the data sources that went into it, you've UniProt, you've UniRef, you've UniClust, Magnify, PDB, pulling from all these structured FAIR databases. They are FAIR databases with their own unique data artifacts within them, but you take them and you transform them into this AI data set, which is generally you're having different mixes of these, is kind of represented by the three different columns. You almost always will have your training and your testing data sets, and depending on your method, your validation sets. And these are all kind of different mishmashes, again, using from those original data sources. And you've created this new artifact and asset, which in OSAI, we're arguing that you need to have a home for this unique asset. Yes, it's a remix of pre-existing stuff, but it's very important for reuse, reproducibility, that these are made available in safe spaces and give them a home. So again, the UniProt protein data is in UniProt, but once you've mixed this all up together with the Magnify data and so on, and have these new unique data sets, AI data sets, where do they go? And so often these are left unregistered and not deposited anywhere. They might be hung off of a GitHub link or maybe put in a drive, but not in a structured format or a fair and open database. Quite often you won't find them. And there are current limitations with those that are out there. So such things like trust. So if you're going to Kaggle and you are reusing a data set, or if you registered it there, it's very easy to put stuff in there. And I've linked off of a recent publication or preprint about the provenance issues of data sets that are going into Kaggle, and people are training up their new models on it. And these are proliferating across scientific publications and peer-reviewed ones. But the provenance sources, they can't be found, and there's no trust in that data of where it's actually come from and if it's legitimate or not. And that's quite a nice one as well. People should check into that. There's also issues with domain focus. There might be the perfect registry, but it's where you could register your AI data set that you've put together, but it's not available for your subdomain type. We've the bioimage model zoo, which is for bioimaging models, and so that might be within scope if you've a different data set type or genomics or so on. And like I know there's Kipoi for different ones, but that's another issue. So it's hard to actually make these choices. And then of course there's the aspect of the metadata variance across these, and there are some of these upcoming standards like Croissant is proliferating and penetrating some of these registries for the data sets, but it's not yet standardized, and all of these impact where you even would put these for their home and where you register them. So it's not an easy landscape out there or a clear thing where you've, for example, your magnified microbiome sequence data, which you might have a clearer home to register and put that artifact, and same for PDB for protein and structural data and so on. And something to flag that is actually quite nice and that's very recently kind of been announced by EMBL EBI is this BioAI repo. So it's life sciences specific. It's a new skin on the bio studies, so operated by Ujas Sarkans at EMBL EBI. And I've linked out to info on that, but it's quite wide biodomain scope. The metadata is quite flexible, but again, they're looking at the right standards and how to better structure that. And it's a new home for both models and data sets. So there are things coming online. And again, that's a nice trustworthy source where people can register their stuff from EMBL EBI, which is a good provider of well provenance and traceable data sets. Looking at models, then looking at the research software management aspects and models as important artifacts. So there's lots of different key software components that should be made available for your AI models themselves when you're publishing these. So for example, all of the data processing steps, if that was automated and you've pulled these in from all these different sources, again, and how you've processed those, there should be reproducible workflows, such as a Nextflow workflow and so on, and that's important software to make available. Additionally, for all of the model training steps, so all the software info files, configs, and all of the really specific nuances around this to make it reusable and reproducible if people want to go train and expand upon this method and model. Creation step is, for example, the random seeds, the epochs, the hyperparameters, and there are certain formats as well that help with some of these things like ONNX format, which is framework specifics in different ways, but there are some solutions out there, especially to help share those in a standardized format and for the software aspects. And again, framework specific if you're using scikit-learn or other different ones to actually train your models. And then you have the actual model, the inference model itself, once it's actually all there and ready to go. And again, the software info files and configs, but also additionally making sure you've a huge focus on the redeployability and robustness that others can actually redeploy these. So making sure that there's containers so it can be portable across systems is very important. All of these software aspects are absolutely key to make sure that your methods are reusable and supporting reproducibility. And but if you look at journals currently, and we've done some different interviews with various journals, and we lovely guy from Taylor and Francis, but he was explaining that this stuff even right now they're still working on data availability statements, not data availability mandates, but just even the statements that go into across the journals. So it's hard to penetrate across the journals and the mandates, but it's important that we stress that this software is deposited and actually made available from all different sides, funders, journals, and so on. So that's something that needs a lot of work in different sides. But for example, maximizing output, and there's different places you can start putting all of this software, and obviously a Git-based system, GitHub, GitLab for your active code, but then making sure that it's archived and backed up with, well, not archived, but that there's releases and DOIs for stable deposition of these in Zenodo, for example, and citability. And then also you can have integrations with software heritage. I believe through Zenodo, you can automatically have that pushed for the proper archiving of that as well. So these are really important to make sure we look after these software models, the model software as these unique artifacts that are very important to be available, and all the different aspects that go along with those. And again, making sure there's structured deposition of these, documentation, metadata formats, and so on that go along and support these and the reuse of them, and a lot of nuances depending on your outputs, but again, very important to make sure they're available. So then going back into OSAI, what it actually does. So there's 9 recommendations in total, and there's a mapping then back to the actual specific components. So we've done a large ecosystem mapping of around 350 components that we've made available. So it's not just these 9 recommendations across these areas, but you can actually find map toolings that can help you, and that they're agnostic as well. So again, you might prefer one or the other, or one might suit your needs for one or the other, for example. And the reusability, we've the 3 core aspects, such as making sure that the metadata for models and data sets are available, that you're using registries for your assets so that you're registering there somewhere. So for example, if your model that you're registering on a Hugging Face or a domain-specific one, with the right metadata that you need. Training, making sure that you're actually hosting, promoting, and sharing trainings on these, as there's a huge gap in this space on all of this, and then that this is available for others. Reproducibility side of things, making sure that you're using clear disclosure frameworks. So DOME is one example, but there's a model openness framework and so on, many of those that we've landscaped and we recommend. Portability, making sure again that the code and environments are reproducible. Standardized evaluation, so again, making sure your benchmarking is robust and done properly. Additionally, sustainability side of things, making sure that you're using green AI techniques to reduce environmental impact, that you're tweaking and optimizing hardware and hardware choices based on what you're working on, and then reporting that impact out the far side. And if we take the case of the sustainability, we map these recommendations, so our 7, 8, and 9, back to different asset or different registered components in the AI ecosystem that we've landscaped with OSAI. So you can see Open eBench maps back to R6 and R9, so you can report your environmental impacts on your Open eBench reporting. But additionally, then for the standardized benchmark data sets, you can find these on Open eBench, for example. Looking at it in how you can then take it one step further and chaining these into different pathways. So you actually take the recommendations, the tools, and have it in a sequential pathway that you can actually have as either subdomain specific or help support users to actually follow along with these. So you can have the recommendation of apply your AI model development, green AI model development practices from using info from green software patterns. Make sure then once you're doing your experimentation, you measure the environmental impacts, such as using Carbon Tracker to calculate those metrics, and then actually making sure you report these back at the end using something like Open eBench where possible in the right community to do so. We do have a web resource. It's quite synergistic identity-wise to the DOME website. And again, it covers all of those things in much more detail that I've kind of done a bit of a hack job to rush through there. But again, you can read these in your own time and get more info on those. There are, again, then the actual guidelines in details under the guidelines tab. And we do have these labeled by levels of importance, which was recommended. Again, people only have so much time, but if they're looking to see what's most important to do in limited time and limited bandwidth, there's some guidance on that, and that came back from the reviewer feedback as well. This is the reproducibility page and the environmental sustainability. This is all under the guidelines. I won't go through them in detail, but you can read those in your own time if interested. And then we actually have the open and sustainable AI ecosystem, which is a very simple GitHub. Well, it's a YAML file that feeds this with a simple UI that you can filter. So you can filter by the OSAI recommendation and find components that can help you actually achieve that recommendation. So as we mentioned, that was quite a big thing. And additionally, people can contribute new components on GitHub. And again, that'd be really great once we launch the paper and get that out. And of course, then there's things like we're working towards interlinking with existing. We don't want to be replacing or having redundancy. So we're working with a lot of ELIXIR resources and registries that already exist. Ours is very specific, very much on our guidelines, but again, making sure that we populate and cross-exchange back to the relevant registries. So fair sharing, have this AI resources catalog. Then so Alison, I believe, is on the call, and we had really fruitful asset exchange between both of our our sources. And fair sharing is absolutely fantastic. It's more standards, databases, and a bit of a more limited scope than what we're open to hosting, as we have a lot of tooling, which is well, we can link back to bio.tools and so on. But a good amount of scope there for other Elixir resources, reducing redundancy, building the ecosystem of asset exchange as well, for helping link people to the right tools to achieve, for example, in our case, open and sustainable AI. As mentioned, it's on GitHub. It's a simple YAML format. We took a lot of inspiration and really thank the RSQ kit, Everse, and Research Data Management Kit folk for their formats, and we're trying to be compliant with those where possible. So a simple YAML, people can add things or log an issue and so on. We'll add things and integrate them in. And again, enrichment with different resources, and in the future, OpenEbench and EuroPMC for publications that are important to index as well from our side. This is generated by Gemini Nano Banana, so it's not perfect, and the descriptors are not great, but just for some icons and simple kind of what's hosted within there. But again, metadata formats that are important for models or data sets, different kinds of registries where people can register them. So your Hugging Face, Kaggle, making sure those are available and findable, but also the subdomain specific ones like Kipoi and BioAI repo, Bioimage Model Zoo, and so on. Benchmarks and that are important, and everything else there in between that we can index. We do have a very simple pathways where we kind of chain those together. They're not perfect, and we're open to improving these over time, but it was stressed to have kind of the sequential important sharing of these as we got the publication together. And we do have one toy example as well on that pathways page, which is far from perfect. It's very hard to find an actual published study that has done everything perfect in alignment with our recommendations, but we have pulled out some ones where most are met, but again, one or two of these are not properly met. For example, the croissant dataset metadata isn't available for this, but the Fairfair-Mel one is. And that was stressed by the reviewers as well, that we had something in there. But this is one of those pathways, and to stress with this, where we see these actually ending up in this community specific ones and guiding pathways and chain together implementations are the resources that already exist. We don't want to be replacing these, but amplifying the supports of how to build these. So for example, in research software quality kit, the RSQ kit of Everse, or the research data management kit of which came out of EOSC Life and other funded projects as well, where they can feed in these pathways and have them existing, not just sitting on our static site, but already living in existing toolkits, not to be replacing those, but cross-link to those. So we do cross-link to those at the top of our resources as well, and encourage people to deposit those and build these kind of subdomain specific pathways of how people have chained these together, implemented the guidelines, and can share that for others in a very grounded, concrete way. If you've done a genomic study, for example, created a genomic specific artificial intelligence prediction model of sorts, and where you've registered things, what you've done, what metadata standards, and so on. For the future, to tie this up then, so obviously, as mentioned, the toolkits are the next big thing, that we can start getting people building these into the toolkits, and making sure these implementation pathways are available to help guide people so they can follow along, and that they're subdomain specific, tailored, or even just a bit more agnostic, but actually done properly with a lot more concrete grounded supports. And of course, the ecosystem landscape and growth. So getting those new assets in there, even since we published this, there's probably 100 new things we could put in there, and metadata standards quite often coming up, new supports there. And of course, the fair sharing, they have this dedicated AI resource collection, so we'll continue to exchange with them and vice versa, and build links with bio.tools. Future extensions, obviously, maybe not through OSAI, but other ways, that ELIXIR, where there's gaps in responsible AI, trustworthy AI, explainable AI, agentic AI, large language models, just biological ones, and ethical AI. So a lot of work and guidance needed in that space, and possible tooling and template supports for that. AI-ready data, that's something that ELIXIR is not yet solved through their international groups, and is important and needs to be looked at. The AI Bio UK group, and I think Charlie, Justin, and maybe some others from that group. It's a fantastic project, but there's an AI readiness group, which hopefully they'll have output soon on that, which you can feed back and align into ELIXIR and see how ELIXIR adopts in that space. And of course, domain agnostic growth, such as the EOSC and the science clusters, to see where we can start aligning across domains and see what cool stuff they have and how they're approaching it. We can knowledge exchange. Huge thanks to my PI, Silvio, Federica, my supervisor, and Alex and Omar, who work in parallel on a lot of the resources. Carol in a gold border here because she was absolutely stunning and fabulous to help get this together. I really couldn't have done it without the support of Carol in this. I think it was a Sunday evening. She had said, "No, I'm too busy. There's absolutely no chance of time for this." And then I started getting all the pings and the feedback, and it was just phenomenal and really got this across the line. So huge thanks to Carol, the machine learning focus group members, Fotis, the co-PI on this, and Layla as well, who leads the focus group. And of course, a lot of the ELIXIR UK folk, Alice and Susanna for the fair sharing assets exchange and collaboration there, Shenya and Robert for helping link me in with this, and of course, Ariadna as well. And of course, Carol and Shoaib as well from UK side. Thank you very much, everyone.